curriculum, there was one particular assignment in support vector machine. So the data or the business problem was that a classic problem in field of image pattern recognition, where that there is a handwritten digit are there, and we want images are there, and we want to identify which digit is that. So suppose we have an image of digit submitted by user via scanner, a tablet, or other digital devices. So the goal was to identify a model and develop that model where which can correctly identify the digit in particular date in that image, digit or of course 0 to 9. The dataset was a standard dataset called MNIST, and each image has 28 pixels in height, 28 pixels in width, and so total 784 pixels, and each pixel was a single pixel value associated with it, indicating the darkness or lightness set, and the pixel value was again integer between 0 to 255. So once I got the data, I divided into training and testing data. It was around 70% I used for training, as in 30% was testing. The first started with the linear model using linear kernel, and then proceeded with the RBF kernel, where I got the accuracy of around 94-95%. Then for so it was one method. So after that, followed with the hyperparameters tuning, and I got the least accuracy of 11%. So I did not proceed with that particular node. So finally, polynomial method kernel was used, and I got the accuracy of around 93%, which was again acceptable. And we performed the cross validation on entire dataset as well, and the value was again 94%. So the test result and on the test dataset, on the entire dataset, was matching, almost matching. So it was a good model, and the conclusion I got that we can use the polynomial SVM method to identify the handwritten digit with around accuracy of say 94-95%, and it was submitted to our case study. And the important the observation while studying the performing the assignment was that whether we can use whether it is a linear regression model or not. So yes, SVM is a linear regression model type, because the most of the data is numeric, and we can use to build the model. Also, even if there is a non-linear data set, and if there are non-linear models, can SVM work for them? Yes, it can work, because whenever there is a non-linear data, we though could not draw a linear hyperplane to separate the data set, or we can call it as a support vectors. We take help of a kernel, and to find the pattern and high accuracy, and to learn the model. So the SVM provided advantage that yes, once we establish the boundary between the hyperplane, the most of the training data is redundant, and all we need is a core set of points which can help to identify and proceed to learn the model. And there are certain hyperparameters which can be used to build the SVM. A couple of them are C and gamma, which are used to tune using cross validation. And the basic support, what is the support vector, or what's called as support vectors? That support vector is a classifier, because instead of support, whenever we have data, we plot it, and we check that the nearest point in which are near to the boundary are called support vectors, and those points are closest to the hyperplane, and these are used to build our support vector machine model. So that's it from my side. Thank you.